All right, 68 here. Mackenzie, what's the equation? F of x equals
3x squared plus 12x minus 5.
plus 12x minus 5. All right, you got two questions. Does it open up or down, or does it have a minimum or maximum, right? Or what is the minimum or maximum? And then B is range, correct?
Mm-hmm.
Thank you. Somebody answered. So A is max or min, and B is range. Logan, any idea whether it's a max or min?
It's got a max.
Or?
Min.
Good. Got it.
That's what I was thinking. I was
That's
just
what
seeing if you thought the same thing.
I'm just checking. So it is a min because that opens up. You know it opens up because it's a positive 3 in front of there. So it's going to open up. It's going to have a minimum. To find that minimum, we need to find the, starts with a V, vertex. We got to find the vertex. Now there's two ways. We can either move it to vertex form, or could you use this little equation, h equals negative b over 2a. Let me do vertex form first, and then I'll do that one, just because you have to do both on the test, quiz, whatever you want to call it, assessment. So for vertex form, this is where, some of you are going, what is vertex form? It's when we write it like that, and then H and K are your vertex. The book also calls it standard form for that one. So we're going to convert it to that for the first part, and then I'll show you the second part on here. To do this, we work with the 3x squared and the 12x. You can't have a 3 in front of there. In the past with circles, we divided by 3. It's not going to be very beneficial here because we also have to divide this f of x by 3. It's just going to gum everything up. So f of x equals, factor out the 3 out of those two terms. You got x squared plus 4x plus, and then we'll complete the square there in a minute, but I still have my minus 5. All right, at all times when I'm working, this function is equivalent to the original function. Like if you would manipulate it and distribute, you're still going to get back to where we were. It's going to be exactly the same as we continue to work. All right, what goes in the first blank there? You take half of 4 is 2. 2 squared is 4. Since I'm working on one side, I got to basically keep this at a total of 0. Well, what does that 4 amount to with that 3 out in front? You got to take 3 times 4, which is 12. So how do I counter that to get it back to 0? Negative 12. So this needs to be a negative 12 here. Now what I got is I got f of x equals 3. That becomes the quantity x plus 2 squared. Negative 5 plus negative 12 will be minus 17. Once I'm at this point, my vertex, remember, it's going to be negative 2, negative 17. Well, what's my max or min, Matthew?
Well, the minimum would be negative 17.
Good. Your minimum is the y value. So our minimum is negative 17. And now you can say at x equals negative 2, but that's not necessary. Just your minimum is negative 17. Andrew.
Why can't you just plug in negative 2 into the equation?
That's the second way we'll do it.
Oh.
That's the second way we'll do it. Because you'll have to write it in this form for other problems. So at least wanted to review that.
Okay.
Now, what's our range? Okay. Aiden, what's my range?
Bracket negative 17 to infinity.
Negative 17. Yep, to infinity. All right. Now, what Andrew's saying, why didn't we just plug that in? All right, that's the second way you can do this. So if you have, go back to the original f of x equals 3x squared. Was it minus plus 12x? Plus 12x minus 5. And now if this was the only things I had to answer, I probably wouldn't do it this way. Okay. And then I would just say, all right, I'm assuming you're found -2 by using h equals -b over 2a. Okay, yep. So I would do this, which would be -12 over 2 times 3, which is 6, which does give me -2. F of -2, you would plug it in. All right, you better know what that equals.
-17.
Yeah, better equal -17. Okay, it's because it's got to be your vertex. So if I plug in -2, 3 times -2 squared plus 12 times -2 minus 5, that's 4. That's 12 minus 24 minus 5. It does equal -17. So again, vertex -2, -17, and then we just go through the minimum and the range. Everything would be the same. Okay. So you need to know how to do both. Okay. So if we want a maximum, if we want a minimum, and we got a quadratic, you find the vertex, which is going to come up in the next one, 89. All right. Let's take a look at that. Let's see if we can come up with a function and equation to represent the situation. All right. So take a couple minutes. Bless you. Bless you. From the last section when we did the volume of the box, where we cut out the corners, I kind of made a big deal to make sure you pay attention to that. That will not be on the quiz because it's a no graphing calculator part. That's going to be more of a test question. So I just give you a heads up so you don't spend time overlooking that or looking over that. Okay, so that number 85, I think it was, on the last homework. You will need to know it, but not for the quiz. Quiz is no graphing calculator. I'll give you a red calculator. Bless you. All right, so you should have at least a little bit of time to process revenue. R of X. It's going to be the number of students times the cost per student, right? Which one's the number of students? Is it 20 or 72? 20 students, and then if it's 20 students, it's $72, right? More students go, the cost goes down, correct? All right, now how do I create this situation? So right now there's a revenue. If I get more students, I can lower that cost. Anybody got an idea on a function?
I did 72 minus 2x plus 20 plus x.
All right, good. I'm going to go with the 20 first just because that's how I have it. That is correct. So she said 20 plus x, and then 72 minus 2x. Well, x will be the number of additional students. Number of additional students. So every student that's added, the price is going to drop by $2. So that's how. So if x is 1, you now have 21 students. The price is 20. If x is 2, so on and so forth. All right. How do we determine the number of students and the maximum revenue? We need to find the vertex. FOIL those two together. is 20 times 72, 1440,
Mhm.
minus 40x plus 72x minus 2x squared. So r of x equals negative 2x squared plus 32x plus 1440. You don't need to factor. You don't need to do anything like that. What do we need to do? What do we need to do?
Find the vertex.
Find the vertex. Now you can put it in that vertex form, but I would probably just go h equals negative b over 2a. Okay, just be, I think it's quicker. So in this case here, we got to find the vertex. And I'm going to use h equals negative b over 2a, which gives me the x coordinate of the vertex. All right, you find that x coordinate, read through the problem, and then see what it asks, see if you can figure out how to answer the questions. Because what x is may or may not be the answer that they want, the final answer. You may need to use it, but it may not be the final one. Way to come through. You got all the answers? Just one answer.
Let me find it.
Okay. Read through the problem. I don't want you to just go and go over it again. I should. Two ways to get that.
Oh, yeah.
So we gotta find F, or H. Carter, you got H? It's 8, so it's negative 32 over 2 times negative 2. We end up with 8.
Kind of like,
That would be your number of additional students. Question says how many students, right? And what's your revenue? All right, and there's two ways to answer the revenue question. We'll go over both ways. So right here, this is the revenue function. So you figure out what r of 8 is. And so it's be negative 2 times 8 squared plus 32 times 8 plus 1440. And that's 1568? Okay. Well, how many students? Don't say 8 students. What's the answer to that? It'll be, Matthew?
28.
Yeah, you originally started with 20. We added 8. So 28 students. Max revenue. Max revenue of 1,568. What would be the cost per student? Okay, it wasn't directly asked, but that's something you should also be able to find. We said the number of students, when we set up the equation, the number of students was 20 plus x. So that's going to be 20 plus 8, 28. And the cost was 72 minus 2x. And so that's going to be 56. That 28, the number of students, times 56, also better give you 1568. Okay, so that's the second way you get that answer. So we do know the max revenue, we do know the number of students, and we do know the price per student. All right, good. Homework. 128. Let's take a look at that one. 126. You might want to turn to that. Make sure you know what those problems are saying. 351. And then I'll go over the answers to the evens here in a second. But 120, we'll do 128 and 127. I know 127 is the back of the book. I want to make sure you do 128. What page is that? 351? Oh. Is it possible for the graph of a polynomial function of degree 4 to have exactly one local max and one local min? Okay, so 128 can a fourth degree function, polynomial, I should say polynomial, have one local max and one local min. Exactly one of each. All right, let's go to that. Pick a few of you. Brandon, what do you say?
I'd say no, because you can only have like a max or min, not both, since it's like an even multiplicity or whatever.
All right, he says no. Andrew,
I said no because it crosses 0 4 times.
crosses 0 4 times. Okay. We said no. What do you say, Katie?
I mean, I also said no, but I thought about it like looking at the graph, like if it had one local max and one local min, it would have one side pointing up and one side pointing down, and that's not how that goes.
Okay, good. All right. Everybody's got a little bit different reasoning. The answer's no. Yeah, the answer's no. It cannot. Now, at most, it can hit it 4 times. It doesn't have to hit it 4 times. So, the only thing I'll say about that, because it could hit it once, it could hit it twice, just depends upon the function. And if you graph it, so for like probably like 127 and 128, I like the approach Katie said. Draw that out. Draw that situation out. What does it look like to have one local max and one local min? So just right now, what would that graph be? Put it on your paper and make sure you understand that. What would it look like to have one local max and one local min? Because you may not understand it quite as well as I think you do, or you may not understand it quite as well as you think you do. So if I'm drawing this to have one local max and one local min, there's my local max, there's my local min. Can it look any other way? Okay. Yeah, the only other thing is you could do this. Okay, but can you come up with anything else? What degree does anything, which way does it have to open? Opposite ways, which means it has to be, the minimum degree would be third, but what else could it be? Anything odd. So it has to be an odd degree. So any graph with one local max and one local min has to be an odd degree. Draw me a picture. Like when you're describing something, draw it out. That goes a long way in your explanation. Okay, so that I can see that you're understanding it. Brandon, what did you say? I forget.
I said no, because you can only have a max or a minimum since it's even.
Okay. You could now, if it hits the axis 4 times, you could have multiple. Okay, it's not necessarily reduced to 1, so not perfect at reasoning, but not incorrect. Okay. So, because if it does hit 4 times, what would that look like? And it would have to be multiplicity 1. So technically, I could get 2 mins, right, in a max. So there's different scenarios. I like if you draw out the situation, then you can talk about that without maybe missing a scenario. Okay, for that one. So in this case here, has to be an odd degree. If it has, so it has to open in opposite directions, has to be an odd degree. So no way it can be 4th degree. 127 is going to be similar. What's it say? 1 local max? Can a 3rd degree function have 1 local max?
Mm-hmm.
Well, what's a 1 local max look like? This is the only thing I can think of. What degree does that have to be? More than likely you're going to say 2, but could it be 4? Could be 4, could be 6. It could be that case, but this is a 1 local max. 1 local max has to be what type of function? It has to be a even degree. Okay, so again, pictures go a long way in an explanation for this. So you're going to draw that out. That would be good. All right, for the other ones, I'll go through 48 in a second. The answer to 48 is 2 or 3. Here's some of those other ones. Hey, really double check. Like if you make a mistake, usually it's just like a minor error. But if you make an error in the division or the synthetic division, obviously you're gonna get that wrong answer. Doesn't mean you don't know what you're doing, but just double check it. Hey, put that hand up. Or you just checking out the elbow. So you go. right, any question other than 48?
14.
14. I'll do it, that's one. Oh, wait, you didn't get that one. Right there, -3 minus 2 would be -5. You see that?
Wait, how is it over?
I think you just said oh.
Okay.
See that minus sign?
Yeah.
Has to go to that. -3 minus 2 would be -5. Okay? So fix that. And I'm gonna tell you 9 times out of 10, if you made a mistake here, it's like with that subtracting part. Okay, for those. I answered her individually, but anybody else want to see it? 14? Matthew says I got them all. Okay. Did you get 48, Matthew?
I did.
Nice. Did Dakota?
I forgot to include the X cube.
Oh,
Oh.
wait, no, I didn't get 48.
Oh,
I
you didn't
forgot-
either?
I forgot to include the execution.
So it's still a tie.
Wait, what'd you get then, Dakota?
You mean the 48 I told you to put the X cubed
I
in?
solved it, I still got negative two.
I got.
Yeah, you can take it without the X.
Okay.
I actually
Oh.
I got 1.5.
I got.
1.5. All right, here's 48. Now, because it doesn't have the X cubed in there, it's a little deceiving. Here's your coefficients. K squared, -3K, -2K, and 6. Those are your coefficients. We're dividing it by X minus 1, which means we put 1 in the box. Always start with a 0. K squared, right? K squared times 1 is K squared. I can't add those together, but I just represent it as an expression. K squared minus 3K. Multiply that times 1. That's where I get the next one. Add, I get K squared minus 5K. Multiply it by 1. That's what I get over here. I got the 6. If that is a factor, the remainder has to equal 0. So we just say, all right, K squared minus 5K plus 6 equals 0. And for 47, and the one we did in class, those are ones that you could probably trial and error, guess and check, figure out. This one's going to be a little bit harder because you probably get one answer and you'll miss the second one because you'll stop if you figure it out the first time. But make sure you can go through here, using this format. All right, anything else? I'm going to give you a review sheet. Answers to the review sheet are on Canvas already. I'm going to suggest to you now that you get your notes out from section 3.1. That is what people forget the most. If you do have any questions, because these first few are from 3.1, they're missed more often than the other ones. Use your notes or I can give you a hand if you can't figure that out. So I would do that. And then check your answers to see if you're writing them in the right form. Don't assume